Hi guys, Dr. B here. This is topic 3.2, properties of solids in AP chemistry. The objective today is to be able to explain the relationship between the macroscopic properties of a substance and the particulate level structure of the substance and the interaction between these particles. So we're going to look at different types of solids today, four basic types, and you have to be able to recognize them and do particulate level representations of these. The four basic types are ionic solids, covalent network solids, molecular solids, and metallic solids. Solids are classified by what type of component occupies the lattice points. A lattice is a 3D system of points designated positions of the centers of the components of a solid, atoms, ions, or molecules. Many properties of liquids and solids are determined by the strengths and types of intermolecular forces present. So the first type is ionic solids. They have ions, sorry. They have ions. They have ions at the points of the lattice that describe the structure of the solid. Due to the strong interactions between ions, ionic solids tend to have a low pressure, vapor pressure, high melting points, and high boiling points. The interaction between the positive and negative ion is known as electrostatic attraction and can be described by Coulomb's law. According to Coulomb's law, smaller ions and ions with higher charges will have stronger attractions between the ions, resulting in higher lattice energy values. They tend to be brittle due to repulsion of light charges caused when one layer slides across another. They conduct electricity only when the ions are mobile. They're generally between a metal cation and a nonmetal anion. So here's a quick example. You can see how the ionic radius it changes when you lose or gain electrons, causing the attraction between the two. Covalent network solids. Solids have atoms at the lattice points with strong covalent bonds to form a solid that might be viewed best as a giant molecule. They're only formed from nonmetals. They can be elemental, like just carbon, so diamond and graphite, or binary compounds of two nonmetals, silicon dioxide and silicon carbide. So you may have carbon, so it's diamond and graphite, like I said, silicon dioxide, silicon carbide, other nonmetal combinations with boron or germanium. To melt covalent network solids, covalent bonds must be broken. Because covalent bonds are relatively strong, characterized by hardness, strength, and high melting points. They're also rigid and hard/brittle because the covalent bonds are fixed. For carbon-containing covalent network solids like diamond and graphite, they're described here. So diamond, carbon atoms form tetrahedral-shaped covalent bonds with a 3D structure, hence the name, hence the diamond part. Graphite is two-dimensional networks, which consist of layers, with each layer strong covalent bonds between. High melting points. Colorless insulators, stuff like that. For silicon-containing network solids, you have silica, SiO2, which is sand, glass, silica, and silicon carbide, carbon and silicon together, excellent abrasive used to make sandpaper. Molecular solids consist of distinct individual units of covalently bonded molecules attracted to each other through weak intermolecular forces. They're composed of nonmetals covalently bonded together. They have a low melting point because they're relatively weak in comparison to the others. They do not conduct electricity because their valence electrons are held tightly within the covalent bonds. So example of molecular solid is ice, water, has a structure. Other examples of molecular solids, dry ice, CO2, iodine, I2, sulfur, S8, phosphorus, P4, and hydrocarbons and polymers. Metallic solids, consists of metallic crystals with spherical metal atoms packed together. A metallic bond is considered to be a close packed lattice of positive atoms, ions surrounded by a sea of moving electrons. The movement of the electrons causes to be a conductor of heat and electricity. They tend to be malleable and ductile due to the ease with which the metal atoms can rearrange their structure. You have a group 1 metal, a group 2 metal. So the group 1 metals you see for every 1 plus there is a minus. Here for the group 2 metals, so like calcium, magnesium, there are 2 plus charges. So you need 2 electrons to make it neutral. Metal alloys, we've talked about these already. They keep a sea of electrons so they will still conduct. Substitutional, interstitial, we talked about these already. Biomolecules and polymers. In large biomolecules or polymers, non-covalent interaction may occur between different molecules. These depend strongly on the shape of the molecule. If you look at this protein, you can see where 2 parts of the same strand are attracted to one another. This forms a secondary structure of a biomolecule and gives its shape. So DNA it's kind of like with DNA, how they're able to interact with each other, hydrogen bonding, etc., but it's doing it within its own self, because you can see it kind of goes like this. This is a bunch of carbons and hydrogens here, and it just kind of folds on itself and they're attracted to each other. A little bit of introduction to biochemistry, by the way. So this is a brief summary of the different types of solids. You see ionic, molecular, metallic, network. You might want to review this because it's a good way to summarize what we just covered. Properties of solids for ionic, molecular, covalent, and metallic. Again, stuff you're going to want to cover, stuff you're going to want to know. So make sure you review these, please. The general increasing of strength of interactions in a solid. So you'll notice that ionic and metallic are pretty equal. Covalent is the strongest. Molecular is the weakest of the 4 types of solids. Carbon dioxide melts at negative 78 degrees Celsius, while silicon dioxide melts at that large number. Identify the type of solid each substance forms. So what is CO2? And then what is SiO2? Carbon dioxide is a molecular solid because we're talking about it melting, so melting is from solid to liquid. And then silicon dioxide is a covalent network. Justify the difference in melting points. CO2 So CO2 is a molecular solid, therefore when it melts, only IMFs are being broken. These are the weakest forces, so little energy is needed to melt, which results in a very low boiling point. SiO2, silicon dioxide, is a covalent network solid, therefore when it melts, covalent bonds must be broken. Covalent bonds require a large amount of energy to be broken, which results in a very high boiling point. So for this, justify the difference, CO2 is considered a molecular solid versus SiO2, which is a covalent network solid. So there's a little bit of difference between the both, so make sure you're aware of that and recognize what makes up, if you can know what makes up a covalent network, so the SiO2, diamond, graphite, anything with silica, silicon and carbon, that's a covalent network that will melt covalent bonds and requires a lot of energy. CO2 is just a molecular solid, so only IMFs are being broken. So hopefully you heard all that and wrote it down. Classify Cl2, Ni, Bn, and FeS as ionic, molecular, covalent network, or metallic solids, and arrange them in increasing melting points. So we have Cl2, Ni, Bn, and then FeS. So this is ionic. This nickel by itself is just a metallic. the boron and nitrogen, that's covalent network. So that Cl2 is just a molecular solid. So we know that molecular solids are the weakest, and we know that covalent network is the strongest. So the last two, ionic and metallic, they're about the same, right? So you can just put the FeS is similar to nickel. All right, guys, that's it for now. Let me know if any questions. Hit the like and subscribe and all that. Thanks, bye.